very good afternoon to each and everyone present over here. I'm Rashmi Rekha Sahu, a research scholar under the guidance of Professor R.N.P. Chaudhary, Shiksha o Anusandhan, deemed to be university. Today I'll be presenting my poster on the topic Functional Aspect of Ferroelectrics, an informative review. To begin with, let me define what is a functional material. Any material which is not constrained or confined by their definition and intrinsic properties, rather can perform a wide range of applications are termed as functional materials. We can say that these are the materials whose output can be manipulated to obtain a specific objective. Here I'll discuss about ferroelectrics as functional materials. The functional aspects that we'll discuss in this poster presentation are ferroelectric photovoltaics, low-dimensional ferroelectrics, ferroelectric nanoparticles, ferroelectric emission of electrons, and ferroelectric liquid crystals. To begin with, ferroelectric photovoltaics. Here we'll discuss about why ferroelectric materials are suitable candidate for photovoltaic application and how they are better than semiconductors. As we know that in a semiconductor, the process of photovoltaic effect is that on application of a photon of certain wavelength corresponding to the electronic band gap of the semiconductor material, there is a generation of electron in hole pairs and then followed by separation of these charges and then the generation of the photocurrent. But here it essentially depends on the electronic band gap of the material, and also the depletion region, the space charge region is capable or is the main important factor which induces the separation of the generated charges. But we see that in case of ferroelectrics, we do not depend on the electronic band gap of the material. So that in turn helps in higher optical absorption. And also we are not constrained by any space charge region. Unlike a semiconductor, we are not constrained by any space charge region. So we can apply any kind of ferroelectric material, just keeping in mind that it should have high optical absorption, electrical conductivity, and mostly abundantly available in nature. So this is one of the functional aspects of ferroelectric material, that is ferroelectric photovoltaics. Next, coming to low dimensional ferroelectrics. Here also we have seen that various perovskite oxides like BaTiO3, PbTiO3, lead titanate, BiFeO3, SrTiO3, they have proved their potential in reduced dimension by retaining ferroelectricity up to much smaller values. And thus their integration with various electronic components has given us miniaturized electronic devices. Next, we'll discuss about ferroelectric nanoparticle liquid crystals. This is a very interesting application of ferroelectric materials. Now, liquid crystals are substances of the materials which exhibit properties intermediate in between that of true solids and liquids. Thus, this is one kind of alignment property that is seen in liquid crystals. Similar to them, ferroelectrics also have electric dipole alignment, which is sometimes spontaneous, and also an application of electric field. So both these ferroelectric materials and liquid crystals exhibit alignment property. So this can be harnessed and their combination can give us various enhanced display devices. Next, coming to ferroelectric metamaterials. Metamaterials, as we know, are interesting materials since these exhibit properties which normally do not occur in nature. For example, materials with negative refractive index. Similarly, here we can integrate ferroelectric materials with metamaterials to have enhanced properties. As we can see here, it is a BST capacitor and here it is a BST loaded SRR, that is a split ring resonator. These are made up of BST, which is a perovskite material, is a ferroelectric material, and thus it can have also enhanced properties. This capacitor can have enhanced properties. So this was ferroelectric metamaterials. The last one is ferroelectric emission of electrons. We observe that due to thermal factors or due to polarization switching and even due to the application of AC electric field, ferroelectrics emit electrons and thus they can act as potential candidates for cathode applications and can act as better than conventional cathodes. This is all about my poster highlighting the various functional aspects of ferroelectrics. Thus, we have seen that ferroelectrics have proved themselves as potential candidates as functional materials and have carved a special niche for themselves in this field. This is all about my presentation, and These are the references. This is all that I wanted to say. I'm very much thankful to Nagpur University for providing this opportunity during this pandemic time on an online platform to present a poster. I'm very much indebted to my Professor R.N.P. Chaudhary sir for guiding me throughout this venture. I'm very much thankful to all the people associated with this NSFD seminar. I'm very much thankful. Thank you.